All right, we're looking at 4.3 dividing polynomials. So in the previous video, or in the previous section, we did 4.2, and that was adding, subtracting, and multiplying. And we had that idea of it being closed, meaning that if you added, subtracted, or multiplied two polynomials, it yielded another polynomial. Down here, we have dividing, and it is not closed. Right? Just like the set of integers is not closed on division. Right? You can find two integers, maybe like 3 and 4, and if you divide them, it gives you a non-integer. Right? This would be like 3/4, which is not an integer. So let's read the little blurb here. When you divide a polynomial f of x by a non-zero polynomial divisor, you get a quotient polynomial q of x and a remainder polynomial r of x. So I think that's kind of hard to see, but they've got a picture right down here. So they took f divided by d, and you got q, and then you had this remainder. And remember in maybe, I don't know, whenever we learn how to do long division, I'm thinking 4th grade, we do some long division and we have remainders left over, right? Not decimals, but remainders. And today we're going to be looking at remainders. Looking here in the second paragraph, the degree of the divisor d of x is less than or equal to the degree of the dividend, which is the numerator, f of x. The degree of the remainder, r of x, will always be less than the degree of the divisor, which is the denominator. You know, there's some neat ideas there, but I'm going to kind of skim over that. Looking down here, when the remainder is 0, the divisor divides evenly into the dividend. One way to divide polynomials is called polynomial long division, and it's similar to regular long division. To me, a lot of these words are really difficult to follow. Whenever we have the words divisor, dividend, what's another good word? Quotient. Those kind of words sometimes are hard to follow, but these formulas here kind of show what we're talking about. We're going to divide a function, so right here we have f, and we divide by d. Whenever we divide, we get q, and then we sometimes have a remainder. Sometimes this remainder here would be 0. So if we look over here at the 107 over 3, right, that's just a normal fraction. But we can think about it as 107 divided by 3, right? 107 divided by 3. You know, and if we think about it as division, we'd probably type it in a calculator and we would get a decimal. But if we think about it as a fraction, it's a lot easier to, my writing is not working. Oh, there it goes. But if we think about it as a fraction, right, the 107 over 3, we know that we're not supposed to have a decimal there. So we would make a mixed number like we did in 8th grade, and we get 35 and 2/3. So whenever you think about 107 divided by 3, the answer would be 35 with a remainder of 2. So that's what we're going to be doing here. We're going to be thinking about the remainders, right? Because whenever you divide polynomials, it's hard to even conceptualize what would the decimal be. But maybe a remainder, right? Like a whole number fraction, or a fraction with whole numbers. Maybe that's a little bit easier to follow. So let's look at number 17. We're going to use long division to divide here. And that's going to be very similar to what we do later on. So we're going to do 107 divided by 3. So I take my 107, and we remember he goes underneath the little house there, the roof, and then we divide by 3. That goes out front. So I look for how many times can the 3 go into the 1. Well, it doesn't fit into the 1 at all. So I look for how many times can it fit into the 10. Well, it fits into the 10 3 times, so I put a 3 above the 10. And then 3 times 3 gives me 9, so I put a 9 below, and then I subtract. 10 minus 9 gives me 1. Now I drop down the 7, and I have a 17. And I ask myself almost the same question. How many times would 3 go into 17? And the answer there is going to be 5 times. 3 times 5 is 15. You subtract that and you get a remainder of 2 there, right? There's no other numbers here to drop down, and 3 does not go into 2. So our answer is going to be 35 remainder 2, right? And we could say 35 and, like a plus, 2/3. This is the way that we're going to want to write our polynomials. So let's try out example 17.5, and we're going to use long division. So let's compare to what we had up here. We had the 107. He corresponds with this piece right there. And then we have the 3, and he corresponds with that piece there. So the pink one is going to go under the house, and then the green one's going to go out front. Now, one of the things that's kind of unique about polynomial division, or polynomials in general, is that if a term is 0, you're able to leave it off. So what do I mean by that? Right here, between the quadratic and the constant term, there's a linear term, and he is 0x, right? Just a 0x, right? Because we go from quadratic, that's that one, to constant right there. In a normal number, the number like 107, the 0, you can't get rid of it, right? You can't write that as 17, right? You can't write it as 17. But with a polynomial, you could just leave it off. So here, the first step that we have to do is we have to put back in all of the zeros. So we're going to say this is 3x cubed plus 2x squared plus 0x plus 4. Right, and now we don't have any, like our place values missing. We have a cubic, a quadratic, a linear, and then a constant, right? Degree 3, 2, 1, and 0. I'm going to check my green polynomial as well right here, and it doesn't skip any, right? We have the degree 2, degree 1, and then degree 0. So now we can build our little division hut thing. I'm sure there's a fancy name for it. We're going to have 3x cubed plus 2x squared plus 0x plus 4. And then over here we're going to have x squared plus 2x plus 3. So up above, the first thing we did was we tried to look at this 3, and then we looked, could it fit into the 1? So down here we're going to look at this guy out front, and we're going to see, can it fit into 3x cubed? Well, no, it can't fit into 3x cubed. We're going to need some extra terms, right? There's 3 terms here on the left, so we're going to need to use all 3 terms right here. Let me undo and get rid of these green markings here. So we're going to ask ourselves, what could we multiply this piece out front, what could we multiply him by, such that we got the 3x cubed to match up? And we would need a 3, and we'd need an x. So now what I'm going to do is I'm going to take my 3x and I'm going to multiply by x squared plus 2x plus 3. Whenever I multiply there, I get 3x cubed, and then 3x times 2x is going to be 6x squared, and then 3x times 3 gives me 9x. So again, what I was doing there is I was distributing this into those 3 pieces, and then I was writing it down there. So now if we look at the above piece, we are at the spot right here with the 9 written. So we're going to subtract that off of my one above. So I'm going to subtract this, and I normally like to put little parentheses here to say that we're subtracting the whole thing. 3x squared minus 3x squared gives you a 0 right here, and that's the way it should always work. The first term there should 0 out. Next up, we're going to have 2 minus 6 giving me negative 4x squared, and then 0 minus 9 giving me negative 9x. Like what we do above, so where are we at right now? We've got the 1, we got this 1, then we carry down the 7. So down here, we're going to carry down the 4. Now we repeat the process. Oop, and I deleted something on accident here. I deleted the 3x. We had him written there earlier, and I accidentally erased it. All right, so we had the 3x, and I distributed him in there, and that's probably when I erased it, whenever I was erasing those swoops. But now we got the 4 down, and we repeat our whole process. We want to see how could I turn in my x squared to the negative 4x squared. I'm going to just need a negative 4. So we need to multiply by negative 4. Whenever I multiply out, I'm going to distribute my negative 4 in. I'm going to have negative 4x squared, and then negative 4 times 2x gives me negative 8x, and then negative 4 times 3 gives me negative 12. Now, like before, I want to subtract these. And the parentheses there are important because this negative here belongs to all three terms. So we have to do negative 4x squared minus minus, so that's going to give me 0x squared. And then negative 9, I'm going to write it over here, negative 9 minus negative 8, that's going to give me negative 1. So negative 1x. And then 4 minus negative 12 is going to be plus 16. Now, I look at my bottom term here, this guy right here. There is no way that I can take this on the left side, the piece that I'm dividing by, and I can't turn them into that. So that's going to be my remainder. So this is my remainder. Oops, my remainder. So my final answer here, and I'm going to try to write it kind of like what I wrote right here. The 35 came from on top of the house, and then the 2 came from the bottom. That was my remainder, and the 3 was the number we divided by. So right here, we're going to say 3x minus 4 plus negative x plus 16 all over 2x plus 3. And that is going to be our answer. Now, if you wanted to check your work, and that would probably not be a bad thing to do, you could take the 3x minus 4 plus negative x plus 16 all over 2x plus 3. That's our answer. And you could multiply that by x squared plus 2x plus 3. Right, that was the number over here. And you could do that if you wanted to. It would take quite a while to multiply out, but you would get the same answer. So again, right here, this yellow highlighted piece, that's our answer. That was polynomial long division. All right, let's scroll down and let's look at another problem. Number 18, we're supposed to divide using long division again. So this piece here is going to go under my house. So we're going to have 6x cubed minus 1x squared plus 12x. And then we have to have our last term written, our constant term. We're just going to put plus 0. Now for our other piece, we have x squared. That's the quadratic. And then we need the linear one. So that's going to be plus 0x and then plus 2 on the end. Now, we look for how could we turn our x squared term, that's our leading piece outside, into our leading piece inside. Well, we need a 6 and we need an x. So 6x. And you see how I'm putting it in the column with the linear piece. Right here we have an x and here we have an x. Right? I'm trying to put them in the same column. Now I'm going to take my 6x and I'm going to distribute to all three pieces here. That's going to give me 6x cubed plus 6x times 0x gives me 0. 6x times 2 gives me 12x. Now I'm going to subtract that off. That gives me 0 minus 1x squared plus 0. And then I could actually drop down a 0 here and have another plus 0. I'm going to put my x in right here by my 0 just so that they have the same degree. It makes it obvious what degree they have. Now I'm going to look and see how could I turn my x squared out front into my negative 1x squared. Well, that would be with a negative 1. So I'm going to take a negative 1 there, and then I'm going to distribute out to these three pieces there. And I get negative 1x squared plus 0x, and then minus 2. I subtract like I did earlier, and I get 0 plus 0 plus 2, right? Because there's a negative out front, then there's a negative in there, so it makes it a positive 2. Now this one's kind of wonky because we have all of these zeros, right? 0, 0, 0, 0. It's kind of uncomfortable, kind of weird how many zeros there are in this one. But if you just follow the process, it does end up working out. So right there, that last 2, here I'll highlight it green, that 2, that's our remainder. So our answer is going to be 6x minus 1 plus 2 over x squared plus 2. Right? And I left off the 0x in our answer because we don't really need that. All right, and there's number 18. That was long division there. Let's scroll down. Where are we at here? Synthetic division. So long division, that's what we just got done doing. And long division can be quite tedious. It can be kind of difficult. But to me, there's very obvious what the pattern is. And maybe it's easy for me to do because I've just done it for so long. You learn it I think we learned it in 4th grade for the first time, maybe 5th grade. And it works very similar to the way that we did it earlier in our lives. Synthetic division is a shortcut to long division. And synthetic division doesn't make quite as much sense why it works so quickly. So I'm going to show you the pattern for it, but it's sometimes difficult to follow along or to understand. So I just want that to be known. Right here it says that we want to divide by binomials x minus k. So synthetic division only works for binomials if you're dividing by a binomial. And in the last 2 that we did, they would not have worked out. 17.5 here. This one was x squared plus 2x plus 3. That one's not a binomial, so that doesn't work. Number 18, we were dividing by a binomial, but it was an x squared. It was a quadratic binomial. And this down here will only work for linear binomials where the coefficient of the linear term is 1. So number 19 here, we are dividing by a binomial, x minus 2. And for starting, we want to get our k value. And k is the number that we have over here. So it's x minus k. And the negative is a part of the formula. So we're going to have x equals 2. Now, we're going to build this upside down division symbol. And we're going to copy up on top, in the top row, we're going to copy the coefficients of the piece that would normally go underneath the house. So here, I'm actually just going to write it out here up above. X squared minus, that's an x cubed, isn't it? X cubed minus 3x squared plus, and we'd have a 0x and then plus 7. Right? Normally you don't have to copy it down like that. We want just the coefficients 1, -3, 0, and 7. Okay? So again, this piece up above, you don't need to write that for all the problems. And then your k value goes out front here. That's 2. Okay, so there's the setup. And the setup is kind of weird, kind of odd why it works. And then here's the process. You just drop down the first term and you put him down at the bottom. And then you take the 2 times the 1 gives you 2, and you put that over underneath the -3 under the next term. And then you add these two terms. -3 plus 2 gives you -1. And then you multiply again. So this is going to be 2 times the -1 gives you a -2. And then you add those 2 terms to give you -2. You distribute 2 times -2 gives you -4. You add those up and you get a +3 on the end. So that's kind of a wonky and odd situation we've got there. This last piece will always be your remainder. And then the piece before it will be your constant. And then before that will be your linear term. And then your quadratic term. So you just kind of count up. You have remainder, constant, linear, quadratic. And if you had another row, then you'd have an x cubed, x to the 4th, and so on. So what we got here is we're going to have 1x squared minus 1x minus 2 with a remainder of 3. And then we don't leave our remainders like that. We need to write it as a nice fraction here. So it's going to be x squared minus x minus 2 plus 3 over x minus 2. Right, and I got this x minus 2 from the very beginning there. There's that x minus 2. All right, again, I want to say that this is an odd way of doing the problem. Well, it's not an odd way of doing it, but synthetic division just seems odd to me in general. It is a little bit faster than long division, and you can get really fast at doing synthetic division. But if you're feeling confused, that's kind of normal for the first time you see it. Let's do another problem, and I'll go through it again slowly. So we look at this problem here. We check, can we use synthetic division? And we can, because because the piece we're dividing by is a linear with a 1 in the very front. So our k we get that value, and that's going to be always the opposite of what's listed, so it'll be -2 in this time. So we draw our little upside down house. The k value, the -2, goes right there. This is k. And then you put your coefficients up here. So our coefficients in this one will be 2, -1, and 5. Right? Our polynomial didn't skip any terms, so we didn't have to have a 0 in there. Now, our first term here, the 2, he just carries down. Then you multiply the -2, that's your k, times 2 gives you -4. Then you add those up to get a -5. Then you multiply your k times the -5 gives you 10. Then you add those up to get 15. And then you count back up. This is your remainder. Then this is your constant. Here I'm going to say constant. And then you'll have your linear, your plain old x. And that's it. We've used all of our terms now. So our answer is going to be 2x minus 5 with a remainder of 15. And we'll go ahead and put him in the fraction. 15 over x plus 2. And there we go. That's number 20. So that's the synthetic division, the second problem with that. So again, I want to say synthetic division can be kind of difficult. Or I don't know about difficult, but just odd, kind of weird. The long division, it does take longer, but it's normally pretty easy. It just takes a lot of time, and you got to be really organized. One of the things, I don't know how much I talked about it, but we kept our columns very organized here. So we had the x column all the way down, and I could have probably done a little bit better keeping those in line, but that was the x column. Then we had the x squared column, and all the way down, that was the x squareds. Whenever you're doing these problems on your own, you really want to try hard to keep them in order, right? So here's the x cubed column. Okay, try really hard to keep those in order whenever you're working them on your own, and it'll probably work out better for you. All right, that was section 3, dividing polynomials.